Here is the lecture for Chapter 11. We will be split into two parts. As usual, it's to try and make it more digestible and easier for you to go through. The main concepts to be covered in this lecture will be method polymorphism, static and dynamic type, overriding dynamic method lookup, and protected classes. I've been hinting about protected now for a few lectures. Here's where we get to go through it. So the inheritance hierarchy that we had in our last chapter in the last section is newsfeed is using post. Message post and photo post are inherited from post. And then we have this display method up here. But what happens if you wanted to have display capabilities down here? I hinted at that in the last lecture. So here's an example. This is what we want in this type of content, and this is what we have today. I don't have the ability to print the file name to make it unique. I can't have the ability to make these slightly different if I wanted to. Right now, I had comments here. I don't have them down here as an example. Okay? The problem is that the display method is in post only, and it prints the common fields because it has to. Because it's in the parent, it doesn't have any awareness of what the child methods have, or child classes have. Therefore, it can only print what is in its own object or class. Inheritance is a one-way street. In other words, the children get what's in the parent, but the parent doesn't get what's in the children. What happens if we actually said, let's have a display down here instead of up here? Now we have code duplication potentially. But if these are sufficiently different, then there's ways to work with that. In addition, in this implementation, if I ended up having another class, I'd have to have yet another display. So place display where it has access to the information it needs. Each subclass has its own version, but post fields are private. So in other words, it can't reach them here. Newsfeed cannot find a display method in post. So if newsfeed is trying to call post, it's got a problem. Static type and dynamic type. A more complex type hierarchy requires further concepts to describe it. Some new terminology: static type, dynamic type, method, dispatch, and lookup. We're going to go into more detail shortly. So what's the type of C1? New car, car. What's the type of V1? Okay. In this case, the static type and the dynamic types will be described in a couple seconds, but basically they're not exactly as you may think. The declared type of a variable is its static type. Declared. The type of the object, a variable, refers to the dynamic. These are the object or the variable. So, the dynamic type, the static type. The compiler's job is to check for static type violations. So right now, because display doesn't exist in the parent, it would actually have an error here. Okay? So, how do you get around that? If we put a display up here, and then we override it down here, now I'm going to work, because it is up here definitely. So back here, the compiler would have found it, and it's in the children. But these have specific code around them that they want. Now, if I add a third type, and I don't care about specific stuff, I can just rely on that one. Overriding. Superclass and subclass define methods with the same signature. Reviewing your knowledge, a signature is the list of parameters after the name of the method. If those are exactly the same in both the superclass and the subclass, and in the parent and the child, then the child one will be called instead of the parent one. If they're different, it will call whichever one it finds first. Each has access to fields of its own class. Superclass satisfies static type checking, which we've talked about, and subclass method is called at runtime. It overrides the superclass version. What becomes of the superclass version? It's kind of gone, sort of. So here's just a simple diagram showing you what's going on. In this case, when you have code here, it's going to go here and look for it. If it finds it, it'll go ahead and go into this code and execute here. No inheritance or polymorphism. the obvious method is selected. Okay, so from here it's looking for it, goes there, finds it. When I do have inheritance but no overriding, in other words display is not here, it goes here, comes up here, says not found, then it goes up to the parent. In this case, if it's in both of them, it comes in and says, oh, here's a display, use this, assuming that these signatures are identical, by the way. It executes this one and doesn't even care that this one ever existed. Okay? That's really clear as mud for some people. So, in this case, no inheritance, no polymorphism. This is exactly how it is. It's going to come and find that one first. Here, with inheritance, it doesn't find this one, therefore it goes up to the top. In this case, it's in both layers. It looks at this one, sees if it matches the signature of the method. If it does, it uses it. If not, it continues its search. The variable is accessed. The object stored in the variable is found. The class of the object is found. The class is search for a method match. If no match, it goes to the superclass. And it keeps on going all the way up until it eventually finds it. If it doesn't, you have a compiler error. This is repeated until a match is found, which is what I just said. And overriding methods take precedence. So in other words, when there's a matching signature, that takes precedence and will go first. With that, that's the end of this half of the lecture. I'm going to go ahead and continue it in another part. Hopefully this was valuable and you got something out of this. As always, send your email questions and I will be glad to help.